Education Society, redefining excellence.
Hello everyone, my name is Mansi Kale. Today I am going to present you PowerPoint presentation on microprocessor, and my team members are Ajitaji, Nisha Bhattigiri and Varadraj Bhosle. And this project is done due to guidance of Professor Gajre ma'am and Professor Khalate ma'am. Now let's see PowerPoint presentation. Today's my topic name is Convert Lowercase String to Uppercase String and vice versa. Contains Introduction, Microprocessor, Evolution of Microprocessor, 8086 Microprocessor, Feature of 8086, Architecture of 8086, Pin Diagram of 8086, Algorithm, Flowchart, Program, Program's Output, Advantage and Disadvantage of Microprocessor, and Conclusion. Introduction. Computer Central Processing Unit (CPU) built on a single integrated circuit (IC) is called a microprocessor. It is a programmable, multi-purpose, clock-driven, register-based electronic device that reads binary instructions from a storage device called memory, accepts all data as input and processes data according to those instructions, and provides results as output. The microprocessor contains billions of tiny components like transistors, registers, and diodes that works together. Microprocessor circuits were first produced starting in 1969, with the first advertisement of a microprocessor appearing in 1971. The Intel 4004 4-bit microprocessor was developed as a central processing unit for a Japanese calculator manufacturer named Busicom. This microprocessor operated at 740 kHz or 740,000 cycles per second. The Intel 4004 4-bit microprocessor was capable of accepting, translating, and communicating 4-bit instructions or words of information. In 1972, Intel released the 8008, an 8-bit microprocessor. Soon after, in 1974, 16-bit microprocessors such as the National Semiconductor IMP16 and the National Semiconductor PACE were offered to the public. AT&T Bell Labs introduced the 32-bit microprocessor in 1979. Evolution of microprocessor. We can categorize the microprocessor according to the generations or according to the size of the microprocessor. First generation 4-bit microprocessor, second generation 8-bit microprocessor, third generation 16-bit microprocessor, fourth generation 32-bit microprocessor, and fifth generation 64-bit microprocessor. Fourth generation 4-bit microprocessor. The first generation microprocessor were introduced in the year 1971 to 1972 by the Intel Corporation. It was named Intel 4004 since it was a 4-bit microprocessor. It was a processor on a single chip. It could perform single arithmetic and logical operations such as addition, subtraction, Boolean OR, and Boolean AND. I had a control unit capable of performing control functions like fetching and instructions from storage memory, decoding it, and then generating control pulses to execute it. Second generation 8-bit microprocessor. The second generation microprocessor were introduced in 1973, again by Intel. It was a first 8-bit microprocessor which could perform arithmetic and logic operations on 8-bit words. It was Intel 8008 and performed improved version was Intel 8088. Third generation 16-bit microprocessor. The third generation microprocessor introduced in 1978 were represented by Intel's 8086, Zeal, Z800 and 80286, which were 16-bit processors with the performance like mini computers. Fourth generation 32-bit microprocessors. Several different companies introduced the 32-bit microprocessors, but the most popular one is the Intel 80386. Fifth generation 64-bit microprocessors. From 1995 to now, We are in the 5th generation. After 80856, Intel came out with new processors, namely Pentium processor, followed by Pentium Pro CPU, which allows multiple CPUs in a single system to achieve multiprocessing. Other improved 64-bit processors are Celeron, Dual, Quad, Octa-core processors. 8086 microprocessor. 8086 microprocessor is an enhanced version of 8085 microprocessor that was designed by Intel in 1976. It is a 16-bit microprocessor having 20 address lines and 16 data lines that provides up to 1 MB storage. It consists of powerful instructions set which provides operations like multiplication and division easily. It supports two modes of operation, that is maximum mode and minimum mode. Maximum mode is suitable for system having multiple processors and minimum mode is suitable for system having a single processor. Features of 8086. The most prominent features of 8086 microprocessor are as follows. First point, it has an instruction queue which is capable of storing 6 instruction bytes from the memory, resulting in faster processing. Second, it was the first 16-bit processor having 16-bit ALU, 16-bit registers, internal data bus and 16-bit external data bus, resulting in faster processing. Third, it is available in 3 versions based on the frequency of operations: 8086 5 MHz, 8086 2 8 MHz, 8086 1 10 MHz. Fourth point, it uses 2 stages of pipelining, that is fetch stage and execute stage, which improves performance. Fifth, fetch stage can be prefetch up to 6 bytes of instructions and stores them in a queue. Sixth, execute state executes these instructions. 7. It has 256 vectorized interrupts. Last point, it consists of 29,000 transistors. Architecture of 8086. The 8086 CPU is divided into 2 independent functions unit. First is Bus Interface Unit BIU and second Execution Unit EU. Pin diagram of 8086. Let us now discuss the signals in details. Power supply and frequency signals. It uses 5V DC supply at VCC pin 40 and uses ground at VSS pin 1 and 20 for its operation. Clock signal. Clock signal is provided through pin 19. It provides timing to the processor for operations. Address and data bus. AD0 to AD15. These are 16 address and data bus. AD0 to AD7 carries low order byte data and AD8 to AD15 carries higher order byte data. And status bus. A16 to A19 and S3 to S6. These are the 4 address or status buses. During the first clock cycle, it carries 4-bit address and later it carries status signal bus. S7 or BHE. BHE stands for bus high enable. It is available at pin 34 and used to indicate the transfer of data using data bus D.Ed to D16. Overline RD. It is available at pin 32 and is used to read signals for read operation. ID. It is available at pin 22. It is an acknowledgement signal from input device that data is transferred. Reset. It is available at pin 21 and is used to restart the execution. It causes the process to immediately terminate its present activity. INTR. It is available at pin 18. It is an interrupt request signal which is sampled during the last clock cycle of each instruction Determine if the process considered this as an interrupt or not. NMI. It stands for non-maskable interrupt and is available at pin 17. Overline test. This signal is like wait state and is available at pin 23. MN/overline MX. It stands for minimum or maximum and is available at pin 33. Int A. It is an interrupt acknowledgement signal and ID available at pin 24. ALE. It stands for address enable latch and is available at pin 25. A positive pulse is generated each time the processor begins any operation. These signals indicates the availability of a valid address on the address or data lines. DEN. It stands for data enable and is available at pin 26. It is used to enable transistor 8286/R. It stands for data transmit or receive signal and is available at pin 27/IO. This signal is used to distinguish between memory and input operation. When it is high, it indicates input operation, and when it is low, indicates the memory operation. It is available at pin 28. QR. It stands for write signal and is available at pin 29. It is used to write the data into the memory or the output device depending on the status of M/IO signal. HLDA. It stands for hold acknowledgement signal and is available at pin 30. Hold. This signal indicates to the processor that external devices are requesting to access the address or data buses. It is available at pin 31. QS1 and QS0. These are Q states signals and are available at pin 24 and 25. These signals provide the status and instructions Q. S0, S1, S2. These are the status signals that provides the status of operations, which is used by the bus controller 8288 to generate memory and input control signals. These are available at pin 26, 27 and 28. When this signal is activated, it indicates to the other processor not to ask the CPU to leave the system bus. It is activated using the lock prefix on any instruction and is available at pin 29. RQ/GT1 and RQ/GT0. These are the request grant signals used by the other processors requesting the CPU to release the system bus. RQ/GT0 has a higher priority than RQ/GT1. Algorithm. An algorithm development process. Step 1. Obtain a description of the problem. This step is much more difficult than it appears. Step 2. Analyze the problem. Step 3. Develop a high-level algorithm. Step 4. Refine the algorithm by adding more details. Step 5. Review the algorithm. Flowchart. Flowchart is a diagrammatic representation of sequence of logical steps of a program. Flowchart use simple geometric shapes to depict process and arrows to show relationships and process or data flow. In flowchart, we use start and stop symbol, process, input and output, decision, arrow, on-page connector and off-page connector symbol. Some points to keep in mind while developing a flowchart. Flowchart can have only one start and only one stop symbol. On-page connectors are referenced using numbers. Off-page connectors are referenced using alphabets. General flow of process is top to bottom or left to right. Arrows should not cross each other. Here is my program. These are my program's output. Advantage and disadvantage of microprocessor. Advantage of microprocessor. Microprocessor is that these are general purpose electronic processing device which can be performed to execute a number of tasks. Microprocessor helps to perform all complex arithmetically and logically instructions. Microprocessor has more power to execute 3 to 4 billion instructions in 1 second and it measures in hertz. Microprocessor is able to transfer used data one memory location to another location. Disadvantage of microprocessor. Microprocessor has various limitations over their advantages as well. Conclusion. Growth is tremendous. Speed of microprocessor is increasing day by day. Architecture has been reduced to very small 22 nanometer. Microprocessors are also used in various devices like mobiles, watches, ATM, cameras. Price reduced in recent years. Much more in the upcoming years. Thank you.
Zeal Education Society. Redefining excellence.